Welcome to Pentol, Additives and Technology for Power Plants. I would like to show you how we can optimize combustion and how we can increase efficiency and reduce emissions at the same time in your power station. Our vision at Pentol is to always look at the big picture, which means we are not optimizing a gas turbine or a diesel engine or boiler without starting by looking from the fuel delivery up to the emission. We look at the whole process and try to identify parts or equipment inside your plant where we see optimization potential and where we can contribute to a better combustion of the fuel. Typically, our products or technologies consist of three parts. One is the protection of your boiler, gas turbine, or diesel engine. Then we do environmental protection. We want to reduce emissions and at the same time try to pay the costs of the whole treatment with an efficiency increase. Pentol is producing the dosing equipment and the additives in our own production site, and we offer the service from designing of the system to combustion tuning in your plant and emission monitoring, assisting clients in the operation of the power station. All of our production is taking place in Germany, so we have our own production plant, where we produce all the additives. We are a family company founded in 1969. A short overview of our activities in Pentol. We've been specialists in combustion optimization for 50 years, and we have experience in coal-fired power stations, heavy fuel oil-fired burners, diesel engines, gas turbines, and currently we are extending our activities to biomass plants and waste incinerators. Let's see how we can optimize a boiler. Our main focus is the incomplete combustion, because we can see that this is typically the origin of a lot of issues and a lot of troubles we have in power stations. That's why we have a look at this very closely. An incomplete combustion leads to deposits. High ash in the power station leads to deposits everywhere in the hot temperature section. And if you go down to the cool section, you will find a condensation of SO3. You would have sulfuric acid deposits, damages from corrosions, and you will get high flue gas temperature. Looking at the emission, typically you get high SO3 and NOx emission. You get solid emission in form of black smoke and of course high CO2 that we can address with optimization of the efficiency. In the first step, I would like to talk about the Pentomol's water in oil emulsion system. Many people think it is pointless to burn water or to add water to fuel, because water by itself cannot burn. But if you take a look at these figures, you will quickly see the advantage. On the left side, we made some tests, putting a heavy fuel oil on a plastic glass stick and burning it over a standard laboratory burner. Here you can see a typical flame. Not very spectacular, because heavy fuel is not really a high-quality fuel. If you compare with the right side, you can see that the flame of the water in oil emulsion is burning much brighter. It extends much larger, and you can see much more activity. The reason for this reaction is the water inside the emulsion is flashing in and is increasing the surface of the flame. I'll show you this in a small graph. If you compare to standard combustion on top, due to the atomization in your boiler, you get a certain size of your fuel oil droplets, and you burn this down in the combustion process to a minimum level, where the fuel will leave the combustion chamber in the form of unburned carbon. And this is the black smoke you can see in the chimney or the dust in the ESP. If you have a water in oil emulsion, the emulsified water inside to droplets will evaporate during the combustion. We call this secondary atomization or micro-explosion. The water will be converted to steam, and therefore the oil droplets will be ripped apart in tiny fractions. Therefore, we have a much higher surface of these, or droplets. They are much smaller. They can burn out completely. This eliminates the unburned carbon going through the system, and you will have a brighter flame, which means due to the complete combustion, you won't have any black particles swirling around in the combustion chamber. If you are measuring your unburned carbon, you'll find out that the unburned carbon is around 80% your fuel. And with this system, we can reduce unburned carbon by about 80 to 90%. In this example, you can see the black ash on the left. It is the typical ash from an oil-fired power station without treatment. At the right side, you can see that the color is changing completely. And the impact is, you have a reduction in total solids going through your boiler, around 60 or 70%. Because you don't have this unburned carbon anymore in the ash, this means if you have an ESP, you'll find that amount of flash that has to be carried away is going to be about 1/3 of what you have now. And if you don't have ESP and all the dust is going through the atmosphere, you may imagine that if you reduce the ash load going into the atmosphere by 2/3, you have a very large impact on the environment. Now see the consequences. In the first step, we reduce the unburned carbon. This means we have a very high reduction of dust load, what leads to a reduction of CO emission that is very strong. Typically, once you start up the emulsion, the CO will be more or less zero, and this allows you to increase or decrease the excess air in the combustion. Because if CO goes down, you have the possibility to tune your boiler and bring it up again by reducing that oxygen. But therefore, by reducing the oxygen, you have very big impact on NOx and SO3 formation or the efficiency of the combustion, as well as the water in the combustion gives you a reduction in flame core temperature. That means that the NOx production you have in the flame is reduced quite significantly. We also have impact on PM10 emission, because we burn out this unburned carbon. So all the particulate matter that could cause cancer would be reduced to a minimum with this technology. On the process side, you have the possibility to further tune the boiler by reducing atomization steam, because we get a better secondary atomization, and you can reduce soothe blowing so far that only 1/3 of the ash is going through your boiler. This means, consequently, you can also reduce the soot blowing to 1/3 because the deposits will be much smaller. Where do we dose pentomoles? Pentomoles and water should be injected ahead of combustion, so typically in between the fuel tank and the burners. You can also produce a stable water-in-oil emulsion into your fuel storage tank, but we typically prefer this location for creating the online emulsion. We can use your blowdown water. Blowdown water is typically available in 6 to 8% of the fuel consumption, so this is a perfect match for our emulsification system. We use your blowdown water, and therefore we reduce your requirement for water treatment for wastewater and reuse it for a positive effect. Let's go to the second step. We have successfully shown you how we can reduce the unburned carbon, how we can have a reduction in SO3 formation and in NOx formation. But we still have the issue that your fuel contains sulfur, and we cannot take the sulfur from the fuel. And the sulfur eventually will convert to SO2 during the combustion, and due to the presence of vanadium and other metals that act as catalysts. A part of this SO2 is oxidized to SO3, which would then further condense to sulfuric acid and cause issues in the boiler. And if you look at the high temperature section, you will note that due to the formation of deposits, your flue gas temperature will rise. You will have to increase the amount of fuel because of these deposits, and therefore you will melt more and more of these metals as you will reduce the thermal conductivity or the heat transfer on the pipes, and the efficiency is going down. And the vanadium pentoxide by itself is corrosive, so you will have corrosion of these pipes. You would have punctures in the pipes, which lead to unplanned shutdowns of your plant. In the low temperature section, we will have the SO3 that will condense. So you get humidity due to the low temperature. You have the presence of SO3. That forms sulfuric acid with a very low pH, and therefore you will suffer from corrosion. You will have a fouling of the system, therefore plugging again and an increase of delta pi. You need water for washing off the air heater. That will further corrode your system. And we have a very low pH. The condensing acid will destroy the air heater. Let me show you the effect of Pentomag in the system. Pentomag contains magnesium, and magnesium is increasing the melting point of the ash, especially of the metals with low melting temperature, like vanadium, sodium, or potassium. And the magnesium inside Pentomag will form a protective layer on the boiler tubes, and you will now see this in examples, that the temperature of the furnace does not have to be increased anymore, because we have no fouling of these tubes anymore. We don't have corrosive vanadium pentoxide layers, and therefore a reduced SO3 formation, catalytic SO3 formation. On the cold end of the boiler, it's even more interesting that this sulfuric acid that was formed previously is neutralized completely. We form magnesium sulfates with a pH that we typically keep above 3.5. With dosing rates like that, we can make sure that we have a corrosion-free environment in this part, and therefore we have no following, no plugging. The other piece stays constant, and the water washing of the air heater is reduced to a minimum. In addition, we have new possibilities. Because we protect the air heater completely, we can adjust the dosing rates of PentoMag to keep it free of corrosion, that we abuse it as a condensate trap. This means before we forcefully reduce the exit gas temperature, now we go through the acid dew point and let as much SO3 condense as possible, because we adjust the dosing rate of the PentoMag in such a way that we don't get any free acidity that would destroy the air heater. This has a very high impact on the SO3 emission. The white plume that typically is present on the fuel-fired boiler will disappear. But in addition, every 20 degrees Celsius in reduction of exit gas temperature corresponds more or less to 1% saving in fuel oil, so there is a very big efficiency gain connected to this reduction in temperature. Of course, this optimization has to be done in cooperation with our combustion engineers, because if you just reduce exit gas temperature without being very careful, you can cause a lot of damage to your plant, and you have to be sure that the treatment is working in an optimal way to prevent any issues. Some words about how Pentol is producing this product. You will find a lot of players on the market who offer inorganic magnesium, like magnesium oxide or magnesium hydroxide. On the other hand, you will find players with the organic magnesium, like magnesium carboxylate or magnesium sulfonate, that is typically used in gas turbines. We have found that due to these mechanisms taking place in the boiler, we were talking about high and low temperature corrosion. The optimum way of treatment is to combine these two worlds and bring together organic and inorganic magnesium, and so far Pentol is the only company of the market that successfully applied these kinds of products where we have 1 part inorganic magnesium and 1 part organic magnesium in one product, and therefore protect the boiler against high temperature corrosion and also low temperature corrosion. It is very important that this is our specialty, where we invested a lot to get optimum blends of these products for every application. Let's have a summary of the technology. Economic balance of PentoMag treatment is improving the thermal exchange rate. We have an increase of performance of soot blowing on the border. We reduce the excess air and atomizing steam. And we have a reduction of unburned carbon in the boiler. And if you can reduce the exit gas temperature by 40 degrees Celsius, this corresponds to around 2% of efficiency increase. A reduction in fuel consumption has a very high impact and is very interesting from the commercial part. And you will also see that we have an improved availability of the boiler, which means that unexpected shutdowns are reduced. Also, the loss of efficiency over time is much less than without any treatment. You can schedule your cleaning intervals in a much wider time frame. If you look on the environmental benefits, this is very interesting. We reduce your SO3 up to 90% if we can reduce the exit gas temperature. Similarly, we can reduce unburned carbon by 90%, resulting in this reduction and total ash formation of about 66 to 70%. We have an impact on your NOx emissions by around 70%. You will see that acid smut fallout will be solved because the sulfonate acid is neutralized by the magnesium, and then you have an impact on CO2 by increasing the efficiency of the boiler. We reduce the fuel consumption in respect to the megawatt production, reduce emission, and increase efficiency. This is the way we would like to act. We believe that we can have an impact on emission without high costs or even while saving money on the operation. And as a reference, we would like to point out that Pentomols has been exhibited on the Expo 2015 on the Kuwaiti Pavilion, where this technology has been shown by the Ministry of Energy and Water of Kuwait as an example of how they reduce the impact of the environment and of their power generation. We hope you enjoyed listening, and if you want to see more about this, please see our presentation from Kuwait by following this link.